Today's video is on mechanisms between ethene and bromine. So let's start off with some key words first. You'll need to know what electrophile is, and an electrophile is a positive ion or positive partial charge on a part of a molecule that will be attracted to a negative area and accept electron pairs. And the opposite of an electrophile is a nucleophile, and instead of accepting electron pairs, it has the tendency to donate electrons. And electrophilic addition is what we'll be looking at today, and we have to break this definition down into two parts. So first, electrophilic, as we've just seen, is the tendency to accept electrons, and an addition reaction is when two molecules join with all the atoms from the original reactants. So electrophilic addition is when we have an addition reaction where the initial attack is on an electrophile, and we'll be looking what attack is and what this all means later in the video. And so we'll be looking at the mechanism of a reaction, and the mechanism just shows the sequence of events about the movement of electrons in a reaction. So for example, if we see here, this is a mechanism and it shows the stages of this reaction through the transfer of electrons, the sharing of electrons. So it's all about the movements of the electrons in this reaction to get the products. And it is key that we know that curved and curled arrows are the ones that show this electron movement. We can't use straight arrows, we have to use curved arrows. So the mechanism we'll be looking at is ethene and bromine. And so the first part of this is understanding that bromine is an instantaneous dipole. So this is because bromine atoms both have the same electronegativity, so there is a even charge distribution across this bond, so the electrons could be at either end at any moment. So partial charges are being created and broken very quickly. And the second part of this is understanding that the ethene molecule that this bromine will be reacting with has a double carbon bond, as you can see here. And this is important because we know that because of this double carbon bond, there is a large charge density because of the 4 electrons in this bond. So this has a large negative charge. And because of this large negative charge, as this bromine molecule approaches the ethene, the electrons in the double carbon bond repel the electrons on this bromine molecule. And this induces a positive charge on the closest bromine atom. So this negative charge repels the electrons on this bromine atom, inducing it to become a positive partial charge. And this is important because if we look at the definition of electrophile again, it's a positive ion or positive partial charge on a molecule that will be attracted to a negative area and accept electron pairs. And if we look at this definition, we realise that our positive bromine now acts as an electrophile because it has a positive partial charge on the molecule, and that is this positive bromine ion that has been induced by the negative charge from the double carbon bond in the ethene. And so next, because of this attraction between opposite charges of this negative double bond and the now positive bromine, the pi bond in this double carbon bond is disrupted because of this attraction. And so the electrons from this pi bond in the double carbon bond attack the bromine. And as I said before, when we show the movement or anything to do with electrons, we use this curved arrow. So we show here the attack of the electrons from the double carbon bond onto this bromine ion. And by attack, we just mean that it attaches and it attracts these electrons. And so this will form a covalent bond between this carbon and this positive bromine. And so after this covalent bond is formed, we will now have a negative bromine ion formed here, and a carbocation, a positive carbon, formed here. And this is shown here. So we have a carbocation, a positive carbon ion, and a negative bromine, because we've now added electrons onto this bromine through this covalent bond. And so this bromine ion that we've just formed here is unstable because it has two bonds, has two covalent bonds, when it really should only have one. So this means that this bromine ion wants to get rid of one of these bonds to become more stable. So one of these bonds has to be broken, and it's the bond with the lowest bond enthalpy, the least amount of energy needed to break the bond, that is broken. And so this bromine to bromine bond has a lower bond enthalpy than the carbon to bromine bond. So this means that this bond here requires less energy to break than this bond here. So this means that this bromine ion will want to break this bond to gain stability. And so we show this electron attack from this double bromine bond onto the outer bromine. So these electrons here will attack this bromine, breaking this covalent bond between them. And because this covalent bond is broken and these electrons have attacked this bromine, this detached bromine will become a negative ion because it's gained these electrons from this bond and isn't attached to this bromine anymore. So you can see here we now have a detached bromine with two electrons from this bond and a negative charge. So this detached negative bromine ion will now be attracted to the carbocation, and this is because opposite charges attract. So this negative bromine is attracted to the positive carbon ion. And so the electrons on the bromine ion attack the carbocation, and this is shown through the curved arrow again. And this attack of electrons from the bromine will cause a dative covalent bond to be formed between the carbon and the bromine. And a dative covalent bond is just when both of the electrons in this covalent bond are from one of the atoms involved in the covalent bonding. So both of the electrons in the covalent bond between bromine and carbon will be donated from the bromine. And so this will now form our 1,4-dibromoethane. As you can see here, our covalent bond is now formed between the carbon and bromine, and we have another one down here from earlier on in the reaction. And it's because of this reaction that the solution of ethene and bromine turns from brown-orange to colourless, because we've now taken the bromine molecules and put them into the ethene molecule to get our dibromoethane. So the colour of the bromine molecules are no longer being shown. So we now have a colourless solution. And what we need to know in the exam is this diagram here. So we see the attack of electrons from the negative double bond onto the bromine closest to the carbon bond, and we then see the attack of electrons from the bromine bonds onto the outer bromine, creating this bromide ion, which will then bond with the carbocation to form this dibromoethane. But you have to understand the entire process to be able to write this out and to explain it in the exam.